So we are having cos raised to a power of 4x. So we are integrating with respect to x. Now we are going to use identities. There's an identity that says when you are given something like sine squared x, this particular ratio has identity 1 minus cos of, we had x here, so we double whatever coefficient x has here. So in this case it's just x, therefore we know there's a 1 there, so this one becomes 2x all over 2. And the second one we have is of cos squared of x. If we have cos squared of x, the identity says it's 1 plus, we still have cos of, we also double what we had here, 2x, we still divide by 2. Now let's try and apply this information in this one. Before you can integrate this one, you need to be able to simplify. If it's in the simplest form, then it's easy to integrate. Therefore, we're going to have, we have cos raised to the power of a 4. So cos raised to a power of a 4 is the same as cos squared x times cos squared of x. We still integrate with respect to x. And then we move again to say, okay, now we have cos squared of x. So we replace cos squared of x with the identity, which is 1 plus cos of 2x all over 2. The same with this one, 1 plus cos 2x all over 2. This is integrated with respect to x. Now we move on to say, okay, let's multiply these two brackets. We multiply 2 and 2, we get a 4. We can now take that 4 to the front and say we're going to have 1 over 4 here because there's a 1 here. So we multiply, we divide it with that 4 in the denominator there. So inside we're going to have 1 times 1. It's 1 plus 1 times cos 2x, and 1 times cos 2x gives us 2. Becomes cos of 2x here plus the last terms gives us cos squared of 2x. This is still integrated with respect to x. Now we can take this 1 over 4 outside, and then we'll be left with everything inside here. Okay, we still have 1 plus 2 cos of 2x. Now here we still identify what we had here. Identify this part as an identity, so we can replace it with that identity and say, okay, let's apply it once more. So for cos is going to be 1 plus cos of, now in this case we have 2x, therefore it becomes a 4x. You still divide by 2. This is with respect to x. Therefore we still have 1 over 4 here. Now let's simplify further. Inside we have 1 plus 2 cos of 2x plus, let's break all of this. We're going to have, we distribute that 1 over 2 plus 1 over 2 cos of 4x here. Let me see. This is with respect to x again. Now I think we can, let's simplify even further again. I thought we are done. We can collect the like terms and say what is 1 plus half. It gives us a 3 over 2 around that. Plus we still have this 2 here, cos of 2x plus 1 over 2 cos of 4x dx. Now that our problem is in its simplest form, therefore we can start to integrate. We still have 1 over 4 here. Now what is the antiderivative of 3 over 2? Becomes 3 over 2, we just add x there, plus we come to this term here, can just keep the 2 as it is. Now we can use substitution for this part to integrate this one, but we can also use a shortcut to say, we remember that the derivative of cos of 2x is a negative sine of 2x. So the antiderivative therefore of cos 2x becomes a positive sine of 2x. But remember, when we do the antiderivative, we must divide by the coefficient of the x inside this bracket here. So it's 2, the coefficient there. So we divide by 2 plus we come to this part. Take out the 1 over 2 again outside. So what is the antiderivative of cos of 4x? Becomes a positive sine of 4x. Again, even with this one, we divide by the coefficient of what we have inside the brackets there. The coefficient is 4. And therefore, we are done. We say all of that plus c, which is the constant. I don't have enough space anymore here. But you can see that from here you are done applying the principle. It's just to simplify. Now you're going to have 1 over 4 outside, and then you work on the inside. This one and this one, they divide. Therefore, you have sine of 2x here, plus here you're going to have something like 1 over 8 sine of 4x plus c. Oh, pardon, that one, not here, but here. Now you can now distribute the 1 over 4 again throughout the answer that you have there, and then you will be finished. Hello, mama, hello.